Hello, I'm Pascal and welcome to another home automator tutorial. If this is your first time, welcome to the wonderful world of DIY electronics with ESPHome. In this series, we are building an over-the-top ESP-based room sensor package using ESPHome. The card to the series is right above here. If you've seen any of my previous tutorials, welcome back. I know that your time is valuable, so the tutorial has chapters which you can access on the video timeline or in the description. If you want to skip to the meaty stuff, go straight to about the TTP233 capacitive touch sensor. See you in a second. In today's tutorial, we will be adding a capacitive switch to our room sensor and building a second ESP32 device with ESPHome to simulate a remote light switch. We will be using an automation in-home assistant from our room sensor switch on and off an LED, thus simulating a switch being put on and off and a light being put on and off. Let me demonstrate. As I pass over the capacitive switch of our room sensor, switches on and switches off. That is what we are trying to do. Now, as you can see, there are two P devices, both running ESPHome, and I will show you the whole lot in this tutorial. Yes, there are other, more efficient ways to approach this use case, but I wanted to share with you one of the simplest way and simplest automation that can be done and how I was going to simulate the new device. For example, you could be using a Wi-Fi, Bluetooth, Z-Wave, Zigbee switch from any manufacturer. I'll be using this setup in this and future tutorial to demonstrate some automations. Though the simulator is not a must for you, it is a must for me to be able to demonstrate to you. I don't want to hide anything from you, so I'm going to give you the code and how to build it as well. Before we start, I'd like to remind you that all of the scripts and commands are on my GitHub page. Links in the description. If you have any question, feel free to leave it in the comments below, and I will try my best to answer you. If you like this tutorial, please like, subscribe, hit the notification bell. This will enable the YouTube algorithm to present this tutorial to more people. Let's get into it. What are we going to need for this tutorial? The bare minimum would be to have a TTP233 capacitive touch sensor and at least 3 jumper leads. Also, if you want to build the simulator, we will need a second ESP32 development board, but an 8266 will just do fine. An LED to simulate a light, a 330 ohm resistor so that the LED doesn't blow up, and a further 3 jumper leads. Software-wise, obviously we'll need Home Assistant and ESPHome. As I explained in the intro, we will be adding a capacitive switch to our room sensor package and creating a new sensor package to test our switch and automations in this tutorial and future tutorials. The simulator is an LED that can be remote triggered, and I will be using it in the next few tutorials in this series to demonstrate movement and presence, and maybe other things. So let's get into the first part. The capacitive switch itself. A capacitive switch is a standard binary switch that has 2 states, on or off. Any given application for any digital or analog binary switch will work, such as switching a light on and off, or a plug on and off. The capacitive switch that I will be using is the TTP22 ESP32 touch sensor. It operates based on capacitive touch technology. Let's see how it works quickly. The TTP223 module detects touch using changes in capacitance. When we touch the surface of the sensor, it changes the capacitance of the touchpad. The module senses this change and responds accordingly. These modules are pre-debonced, making them extremely easy to use. You don't need any direct physical contact with the touchpad, which is actually great because you can put something in front of it as long as it's not metallic. So you can create a housing in front of it that is prettier than the actual sensor itself. So how are we going to wire this? We're going to be using GPIO 12 for our capacitive touch sensor. You could practically use any other GPIO pins that we haven't used yet. I didn't choose it randomly, I chose it for ease of use on my side. I remind you that the following pins are already used. GPIO 26 is for the DHT22, GPIO 21 is the I2C SDA pin, and GPIO 22 is the I2C CSL pin. As for the sensor itself, it only has 3 pins. A VCC, a data or trigger, and a ground pin, as shown here. Before we carry on, here is a view on how the entire board is going to be laid out. Here we are, and here are the boards. We'll ignore right now the simulator, and we are going to work on our sensor package. So as you can see, here is the ESP32, the DHT22, which we installed in our second tutorial in the series, the BH1750 light sensor, which we installed in our third, and the SGP30, which we installed in our fourth in the series, and that would be an air quality sensor. So now that we know what we've got, we are going to add this sensor over here, which is the capacitive touch sensor. I know it's going to be a squeeze, but I am going to put it here. But before I put it here, I am going to literally flip it around. And let me explain to you why I do that. If you look, and I will try to zoom into it, if you look over here, you will see ground, IO, and VCC. So this is the order in which we have to put the wires. So the first one is going to be VCC, and I am going to take VCC all the way from here, from my VCC rail, and it is 5 volts compliant, so I can actually use 5 volts. This is going to create a bit of a mess. I'm sorry about that, but we will be taking off the DHT22 shortly, so I think in 3 or 4 tutorials. Okay, so I am going to take the ground from the ground rail, if it allows me to actually put it in there. There we are. Okay, and the ground, and luckily enough, I haven't done anything with this because the VCC comes over here and the ground comes over here, as you can clearly see labeled on the unit. Inverting it could cause some serious problems like the sensor blowing up. Okay, so we talked about using GPIO 12, and GPIO 12 is right here. And I am going to put the IO in the middle. Now I can safely turn it around and put it here without any worries whatsoever. What I'm going to do now is I am going to fire up the ESP32, wait for it and you'll see it's going to start flashing blue. As soon as it stops flashing blue, it is onto the Wi-Fi, and it seems to have stopped, which means we can go onto the code. Let me see you there. Just reminding you that the code that I'm going to be using now is available on my GitHub. The link is in the description below. So we've defined the GPIO at GPIO 12 on the board. How do we enable this binary sensor? First, let's go into our ESPHome room sensor. And we are going to add a binary sensor. Binary sensors go above sensors. And the binary sensor that we're going to add in this case is a GPIO binary sensor. I am going to copy the code and I'm going to paste the code, and here it is. Platform GPIO, we said GPIO 12 for the pin. The name, I think by now we are all used to using the device internal name, and I've put as a full name capacitive light switch and an icon bulb. And the name is capacitive light switch. Since we are at it, and that we are putting icons into our code, we can find the built-in icons at this address, which I will leave on which I'll leave along the code. It is material designs, and I'm just going to go straight there. These are the icons that are built into ESPHome and Home Assistant. If you want to find an icon, for example, a light icon, you write light and you will see a whole lot of them. In my case, I wanted a bulb. So I am going to go back and bulb. And as you can see, we've got the bulbs here, and specifically the light bulb here. I used the bulb. I will leave the ESPHome documentation as well as the icon website on my GitHub page. And how about we just save this? And we deploy it wirelessly as usual. And whilst this does what it does, I will be fast forwarding and seeing you afterwards. Okay, and the ESPHome room sensor is back online. And we are going to trigger the switch. As you saw, it sends state on and off immediately. I'm going to do it another one, and there we are, on and off.
Several days later.
Okay, let's check and see if we can see a new sensor on the web interface. So what we will do is we will go to Visit, and here it is, and you can see the capacitive light switch is at the top. It is not a physical switch. You will see how we handle it later in Home Assistant through an automation. Okay, just to demonstrate, you can see it's not on, it's not off as I tap it. Next, we will go into the Home Assistant integration, which is in Settings. Oh, I see there is a Home Assistant update. And we'll go to Device and Services and ESPHome, and we only have one active ESPHome device. And we can see here that the capacitive light switch is also showing. And let's see, yes, it is going on and off. This is perfect. We can now move on to the next step, which is the simulator. I will see you there. The best way I can explain the simulator is a device that I needed to simulate or demonstrate some actions that our new room sensor can take. And given that the room sensor mostly controls remote devices, I decided to create the simulator. This ESPHome-based package will be used going forward to demonstrate remote actions. And I will share the code for it, as it may be of interest to you. I do not expect you to build it, but I thought since I was building it, hey, why not? For now, the simulator is used to represent a light and only has one binary LED with an on and off switch, but we will add things to it as we need it. Before we move on to the simulator, I'd like to show you the basic circuit, and that includes my usual 5 volts to the power rail and ground to the negative rail. Also, you'll see that GPIO 12 is linked to the LED, and from the LED we go to a 330 ohm resistor back to the ground. That's all there is to the circuit at this point in time. If and when we add to it, I will show you the updated circuit diagram. Let's not waste time and build the circuit on our breadboard. As you can see, I have the simulator already plugged into the mini breadboard. And what we will do now is we're going to take a jumper, put it into GPIO 12, and put it right here, a little away. If I manage, yes, there I've managed to put it in. And then we are going to take, this is the positive side, the longest one is the positive side. The positive side goes to the data pin 12, and then we will use a 330 ohm resistor that we will plug into the negative and into the negative side of the LED. Then we are going to start it up, and with a little bit of hope, we will connect to the Wi-Fi, because I've already prepared the unit for us. And yes, it has. So a little bit about the resistor. It's there to limit the current through the LED and avoid overloading it and obviously burning it out. In short, always use a resistor. 330 ohms is sufficient in both our 3.3 volts and 5 volt circuits. The higher the resistance, the lower the brightness of the LED. So be careful with that. I will remind you that all of the code is available on my GitHub page, link in the description. Before we start doing some coding, the first thing that you're going to have to do is to get the code from my first tutorial in this series and copy it onto a new device. As such, I've done it already to save time, and let's get into it. So we're going to click Edit, and you will see that I've changed already the substitutions, the device internal name, the device Wi-Fi name, the device friendly name, and the device IP address have been adjusted according to our needs. I've also commented out the Bluetooth and I2C sections. We don't need them, so why put pressure on the MCU? Furthermore, we are going to come down from there and we are going to go all the way to the bottom just before the switch. So we'll need 2 sections for this to work. The first one is output, and I'll put this on top of the switch. Output, and output defines that there is something that's going to be used on the outside of the MCU. So it goes out to a sensor or device. In this case, it's going to be an LED, and the platform is going to be on a GPIO. We have opted to use GPIO 12, and I have given it an ID of light simulation LED. Now, this ID is vital, and you will see why now, because we are going to now define a light, which represents a light that we can switch on and off, and therefore we are going to declare a light of platform binary, because it can be or on or off. The name is a simulated light, and the output is a light simulation LED. So the light refers back to the output. This is very important to understand. So from here, we are going to install this on our ESPHome device simulator. So click install wirelessly, and off it goes. I will fast forward this and catch you afterwards. And the simulator is started. So we are just going to go and stop here. And our next step will be to go and visit the device's web server. Okay, and here is the device's web server. And in the device's web server, we've got a simulated light. Here we are. And this is the light. And it goes on and it goes off. This is local to the device, so we are not yet at a point where we can take the device and do automations with it. Oh, new notification. Yes, it has found a new device, the simulator, so we are going to configure it. Okay, let's refresh and see what happens. Let's configure it again. Submit. Yes, area is not required in our case. We can go to ESPHome, and now we have ESPHome device simulator. Let's go into it, and yes, we've got a simulated light and our standard sensors. Let's see if it works from here. Yes, it does. Okay, so from here, we are gonna hop into the next part of this tutorial. I will also leave all of the ESPHome documentation links on my GitHub. And yes, see you in the next section, where we are going to put both of these devices working together through an automation. Now the real interesting stuff starts. We are going to automate the simulator to react to the capacitive switch on the room sensor package. So how do we do this? First, we're going to have to scroll down a little bit and go to settings. From settings, we'll go to automation and scenes. And from automation and scenes, we can go to create a new automation. This is going to be a brand new automation, and let's add a trigger. Now, the trigger is going to be a device entity. So we're going to look for our device, and our device is room sensors. And as you can see, it already has picked room sensor capacitive light switch turned on, which is exactly what we're going to be using. The duration is irrelevant to us in this case, so we can now collapse this. The next piece is to do the then do. And we're going to add a building block. And why are we adding a building block? It's because we've got a if then. So now you can see we have got an if then, and what we are going to do, if the condition is that the device, ESPHome device simulator, is simulated light is off. Actually, I'd like it on first. we are then going to do an action. And the action is to go to the device, home device simulator, and we are going to turn the simulated light on. So turn on ESPHome. We don't need to flash anything or anything like that. It's going to just happen. Then we're going to do an else, add action, go back to devices. The device again is going to be the simulator. If the simulator hold on. No, this is not. Yes, else turn off. So we're either turning it on if the device simulator is on. No, we're turning it off. And if the light simulator is off, we are turning it on. Okay, this should be it. The new automation. I am going to call it ESPHome light switch. Light. Sorry, I'm going to call it ESPHome capacitive switch. I can't spell. Switch wasn't switch. W. Okay, light on and off. I would recommend that you do a good description for your automations. We are going to save this and let's test it. Let's see if I've got it right. It's switched on and it's switched off. This is really it. There is no big secret. I will share the YAML for this on my GitHub page. So please don't hesitate to go and have a look at it there. So I think we are pretty much finished this tutorial, and I'll catch you in a second. Now that we have a switch and a light, we will be able to demonstrate the basics behind movement and presence sensing, which will be coming soon. I want to thank my Patreon, Miguel Avelo and Stephen Brouillard, for their generosity. Please like, subscribe, and smash that notification button so you never miss a video. Lastly, you may have noticed that halfway through this video, I changed clothing. It took a couple of days for me to do the first part and then the second part. Some issues with my recording software. But right now, this is Pascal signing off, and see you in the next tutorial.